Hello friends, in wavefronts and wave normal, we will be dealing with the definition and types of wavefront and wave normal. So, while defining wavefront, what is a wavefront? The locus of all points. The locus of all points where light reach simultaneously is called wavefront. So, locus of all points where light reach simultaneously is called wavefront. Here we will try to understand the diagram and meaning of locus of points. Here if I have a point source which will try to emit light waves like this in these possible directions. Say I would take a small time t in which each of this light wave reach simultaneously at this, this, this and this point. So what I will do, I will join the locus of all these points. So I am marking the points and the locus of all these points. This will be known as wavefront. So here the thing which is necessary to understand that light when starting from source reaches all these points simultaneously and then locus of all these points is known as wavefront. So what is wave normal here? So what is wave normal? Wave normal. The perpendicular lines in the direction of light rays perpendicular to wavefront are called wave normals. What is the meaning? The perpendicular lines in the direction of light rays and perpendicular to wavefront are called wave normal. Let's try to understand the wave normal. So this was our source and this was our wavefront. Now say I will take this perpendicular lines. Obviously these lines are in the direction of light rays. So these are making 90-degree angle at each point. So these all lines are perpendicular to wavefront and they are in the direction of light rays. What was our definition? The perpendicular lines in the direction of light rays and perpendicular to wavefront are called wave normal. Now let's try to understand types of wavefront. Types of wavefront. Yes, if we are having point source, if we are having linear source, and if we are having source at infinity, then different type of wavefront we obtain. Like see, first type of wavefront is spherical wavefront. Spherical wavefront. Okay, what is spherical wavefront? point source emits light in all possible directions and produces spherical wavefront. Like, see, if I have a point source, it will try to emit light in all possible direction, vertically, horizontally, and all possible direction, like this. So in plane of paper, it might look like circle. In plain paper, it might look like circle, but it's not circle. It's a sphere. Like, say, I'm going to mark these points where light reaches simultaneously, and we'll draw a sphere passing through all these points. So this will be which type of wavefront? Spherical wavefront. Spherical wavefront. And this is our source S. So point source produces which type of wavefront? Spherical wavefront. Now we'll try to understand second type, cylindrical wavefront. Our second type will be cylindrical wavefront. Linear source emits light such that it produces cylindrical wavefront. Like the one we are having in our households. If there is a tube light like this, so it will emit light rays in this fashion. And if you try to join the locus of these points, you will be having locus forming a cylinder. Locus forming a cylinder. So linear source emits light such that it produces cylindrical wavefront. And the third type is plane wavefront. Now try to get the meaning of this, because in this chapter of diffraction we will be clearly using plane type of wavefront only. The source at infinity emits light. The source at infinity emits light rays parallel to each other, and plane wavefront is obtained. The source at infinity emits light rays parallel to each other, and plane wavefront is obtained. What it means that source is at infinity? Really, source is at infinity means somewhere it is in another galaxy? No. Source is at infinity means the source is so much distant from our observation point or our screen, so that from the source, when light ray reach to our observation point, the light rays are observed parallel to each other like this. So when source is at infinity, light ray travels so much of distance, and hence in diverging session it appears for us like they are parallel. And now, if we mark the points where light reaches simultaneously, as per our definition of wavefront, if we mark the points where light reaches simultaneously, then there will be a plane passing through it. So if light rays are like this, parallel to each other, and we mark the points where light reaches simultaneously, then it will be a one plane obtained as an wavefront. So if plane is obtaining as a wavefront, it will be called as plane wavefront. It will be called as plane wavefront. And it will also clarify the picture of wave normal. What was the definition of wave normal? The perpendicular lines in a direction of light rays which are perpendicular to wavefront. So these lines are perpendicular to wavefront. Means light ray itself are wave normal here. Wave normal. So plane wavefront is obtained when source is at infinity. Here I didn't show any source. Why? Because source is at infinity. Means distance is so much high. And in practice, in practical life, how we obtain source at infinity? We took some source which can emit light and will pass that light through lens. So what happens? This will be what happens if we incident light rays, diverging light rays on biconvex lens from source. Obviously, this is what biconvex lens makes them parallel. So this is how plane wavefront can be obtained. So in this topic, we have learned about definition of wavefront, wave normal, the types of wavefront, point source produces spherical wavefront, linear source produces cylindrical wavefront, and source at infinity produces plane wavefront. And please remember the word, if source is at infinity, it actually means that light rays will come parallel. So anywhere if you heard source is at infinity, then it is indicating that light rays will be parallel to each other. Got the point? So this is all about wavefront, wave normal and its types. Thank you so much.